Alrighty. So we have plotted points on the polar coordinate system. We have looked at symmetry with polar graphs. Well, we didn't technically look at it because we didn't look at the graphs and talk about it that way. We just looked at it algebraically. We are going to today look at some other things that help us with graphing, and then tomorrow I'm going to give you the actual graphic organizer that has all the different graphs and stuff on them. So today we're going to find some things, and we're actually going to attempt to graph some without really knowing what these graphs look like, just by some of the behaviors that we have. So it says two other values help in graphing polar equations. So that means other than the symmetry that we talked about. The maximum R values, what do you think R stands for? Radius, are the points where which R is the maximum. Makes sense, I hope. The values for R for which absolute value of R is at a maximum, then substitute these values for R in the equation to find theta. So the reason it's the absolute value of R is we just care about the distance. And since if I'm at 0 and I have a radius of 4, I could also have a radius of -4 and it'd be over here, and it still has a distance of 4 from the pole. So that's why we're worried about the absolute value. Then it says the zeros are the points at which R equals 0, just like, on the x and y coordinates when x equals 0. It's when y equals 0. But to find the zeros, simply set the polar equation equal to 0 and solve for theta. So same types of things that we have done in the past on rectangular coordinate systems. And so here, this first example, we've got this equation right here. Okay, so we want to find the maximum R values. If I take the cosine of theta, what is the biggest number I can get when I take just the cosine of theta? 1. And what's the smallest? -1, right? Smallest I can get is -1. Biggest one I can get is 1. That's it. So cosine of theta, whatever it is, has to be less than 1 and greater than or equal to -1. Make sense? So we're going to look at what happens, since we're worried about absolute value, if cosine theta equals -1, right? So then we're going to substitute that into here. Then that would mean that the absolute value of R is equal to the absolute value of 2 plus 4 times -1, because I'm substituting in that -1 for cosine theta, right? So 4 times -1 is -4, plus 2 is -2. So I get the absolute value of -2, which is 2. Okay, everybody good with that? Then I have to say, all right, well, if cosine theta is equal to 1, then the absolute value of R is equal to the absolute value of 2 plus 4 times 1 equals, well, 4 times 1 is 4 plus 2. It's the absolute value of 6, which is 6. So of those two numbers, which one is the bigger one? 6. So 6 is my maximum R value, right? But I have to figure out at what angle is that happening. So I actually substitute 6 into this right here, and I get 6 equals 2 plus 4 cosine theta, right? So then I subtract, and I get 4 equals 4 cosine theta, which means 1 equals cosine theta. So theta equals what? When is cosine 1? 0 and what? 2 pi. So we're going from 0 to 2 pi on all of these. That's not necessarily the interval that you would use all the time with these, but you don't know which interval to pick yet. So we're going to go from 0 to 2 pi. That might mean in some cases we have some things that repeat, but for right now that's okay. All right. So then we have to have a final statement here, and our final statement is that the absolute value of R is equal to 6 at theta equals 0 and 2 pi. So that means on my graph here, where I'm going to go and plot that, well, at 0, I have a radius of 6, and at 2 pi, I have a radius of 6. So even going from 0 to 2 pi, the 0 and 2 pi overlap sometimes, but there we go, okay? I also need the zeros. So that means I need to know when the radius is 0. So I take 0 is equal to 2 plus 4 cosine theta. So that gives me a -2 equals 4 cosine theta. So -1/2 equals cosine theta So when, from 0 to 2 pi, when is cosine a negative 1/2? 2 pi thirds and 4 pi thirds. Good. So then I say r is equal to 0 at theta equals 2 pi thirds and 4 pi thirds. So let's look at how that gets me some help over here on this graph. First of all, I do know that r does equal 0 at somewhere, so there's a point there. But when I put that, I mean, I don't know which angle that's coming from, right? That's why I have to find this. So at 2 pi thirds is where it actually hits 0. Well, from 0 as an angle all the way to 2 pi thirds, that means there's a radius other than 6, or, well, other than 0 for sure, and other than 6. So that means it's going to swing out something like this. Like it's going to start rotating around, and then when it gets to 2 pi thirds, it's got to hit 0. That is not good. Let me do that again. Sorry. And look, something like that. Okay, where it kind of, it's not like a semicircle. It like comes in and gets a little closer in there. I didn't do that really great. And then the next one's at 4 pi thirds, right? Which means that also happens on this side, so comes out something like that. Kind of looks like a heart, but it's not pointy down there. And these should be, it should be symmetric. I'm not redrawing it again. We're just sketching right now. It's fine, okay? So we're going to go with that. But it's like a continuous curve. It's not a point like a heart, but it does kind of dimple in right there. Now, in this case, and I know you don't know a whole lot about these graphs. So on the assignment, I had actually kind of not put the graphs on there at first, and then I went back and put them, because I want you to attempt it. If they're completely wrong, it's fine. I just want you to start thinking about what makes sense with the information that we have. This -2 radius right here actually does give me some information. Like it's an important part of this. It's just not my maximum. The -2, if I was to substitute -2 in for r, what I get is pi. So I'm just going to tell you that without us doing it. So when I go to pi, my radius is -2, which means I have a point right here. So what this graph actually does is it's, when we start at 0, it comes in, it goes like this, it loops around inside of here, and then goes back out that way. Okay, so it looks something like that. Yeah, if you get something that, if you think that, you know, at the least the heart part without the loop, I think you can get. And if you think there might be a loop, and if you don't know, it's okay. What I don't want you doing on the homework yet, because we will, I don't want you graphing on a graphing calculator or trying to look at the graph itself. I want you to think about what makes sense to you, and then we will go and like actually look at some of them that are graphed for us, okay? Because it's just going to it kind of spoils what you're thinking up until that point. And this one's, as far as you not understanding and going with this one's the weirdest one, and there's not all going to be that, they're not all going to be that confusing if you don't know what you're doing yet. Okay, are we good so far? We at least understand that part. This is just kind of like a little bonus, let's think through it type of thing. Okay. We're going to skip number 2. We're going to go to number 3. And because I'm skipping some of these, because we don't need to do every single one of them, it just so happens all the examples are cosine. That's just a coincidence. I just skipped the sine ones, not because they're bad, but because I guess that's one I chose. All right, so I have this equation now. I want the maximum r value. So now this has cosine of 3 theta. So 3 theta is just some number. Whatever this number is, when I take the cosine of whatever it is, still the biggest number I can get is 1, and the smallest one is -1. So then now here, the cosine of 3 theta, not just the cosine of theta, has to be less than or equal to 1, greater than or equal to -1. Okay. So then I say, well, if cosine 3 theta, sorry, equals -1, then the absolute value of r is equal to the absolute value of 4 times the -1. And that's going to be absolute value of -4, which is 4, right? Then I have to do the positive one. So if cosine 3 theta equals 1, then the absolute value of r equals the absolute value of 4 times 1, which is the absolute value of 4, which is 4. So I got the absolute value of r equals 4 for -1 and 1. So when I go back to find the angles, I have to use both of them, right? So when I go in here and I'm going to substitute in the -4, because even though I get a +4 here for the absolute value, the radius here is still -4. So that means that -4 is equal to 4 times the cosine of 3 theta. And then I'm also going to use this radius here, which is a +4, and that's equal to 4 times the cosine of 3 theta. And then I have to solve both of them, okay? So we'll start with this one. I'm going to divide both sides by 4, so I get -1 equals the cosine of 3 theta. So in order to get that 3 theta away from cosine, I have to take the cosine inverse of both sides, right? So what that's going to give me is 3 theta. It doesn't give me theta yet. When is cosine -1? Pi. Okay, now here's a little part that you have to think through. In order to get theta, I'm going to have to divide everything through by 3, right? My theta has to go from 0 to 2 pi. Well, if I'm about to divide by 3, in order for me to get from 0 to 2 pi for theta, my 3 theta has to go from 0 to 6 pi. Does that make sense to you? Because if this is a 3, I have to triple my 0 to 2 pi range there. So instead of just pi, so I am here, like this is your -1, it's pi. So this is 2 pi. This would be 3 pi. And this would be 4 pi, and then 5 pi. And then that would get me through 6 pi. Okay, so if you have something other than just theta, if it's 3 theta or whatever, that changes the amount of angles you have to have right there. We're used to stopping at 2 pi, but you're going to have to go farther, because now to get theta, I'm going to divide everything through by 3, and I get that theta is equal to pi thirds. What's 3 pi thirds? Pi. And then 5 pi thirds. So in the end, my theta does go from 0 to 2 pi. You with me on that? So now I look at 4 and I solve this one. I get 1 equals cosine of 3 theta. So 3 theta equals, well, cosine is 1 at 0, and then at 2 pi, and then at 4 pi, and then at 6 pi. So now when I divide everything through by 3, I get that theta is equal to 0, 2 pi thirds, 4 pi thirds, and what? 2 pi. Bless you. Okay, so that's lots of angles there. And that means that the absolute value of r equals 4 at theta equals, and then we start with 0, 0 pi thirds, 2 pi thirds, pi, 4 pi thirds, 5 pi thirds, 2 pi. Okay, everybody okay with all that so far? Let's plot the radius. So here's what we have. It's the absolute value of 4 at those. But these 3 right here came from the radius that is a -4, and these came from the radius that is 4, right? So at 0, I have a radius of 4. At pi thirds, my radius is -4. Right here. At 2 pi thirds, my radius is 4. Right? At pi, my radius is -4. I already have a point there. At 4 pi thirds, which is right here, my radius is 4. I already have a point there. 5 pi thirds, it's -pi. I already have a point there. 2 pi, it's 4. I already have a point there. So we end up repeating there because we didn't really need to go that far, but we didn't know that right now. Okay, we good so far? All right. Now we got to find the zeros. So 0 is equal to 4 times the cosine of 3 theta. So that means I divide by 4 and I get 0 equals the cosine of 3 theta. So 3 theta equals, when is cosine 0? Pi halves 3 pi halves, but I'm going to have to go to 6 pi here, right? So if you think on the graph here, we got, this is pi halves, this is 3 pi halves, that's 4 pi halves, this is 5 pi halves. And, you know, all those times you did these patterning things, and, you know, these are my 3 fractions. What do you think the next fraction is? Same type of thing here. What would the next one be? 7 pi halves, then what? 9 pi halves, and then what? 11 pi halves. You see how you're just adding 2 to the numerator every time? Okay, and 11 pi halves, that would give me here, so then that's 12 pi halves. That is 3 or 6 pi. Got around to 6 pi. So now I need to get theta. So I'm going to divide everything through by 3. Is that going to be easy or difficult? Easy. Dividing by 3 is the same as multiplying by 1/3. So I get theta equals, and that's going to give me pi 6. What is 3 pi 6? So it's pi halves. And then this is going to be 5 pi 6, then 7 pi 6. What would 9 pi 6 be? 3 pi over 2, and then 11 pi 6, right? So instead of rewriting that again, we can say r equals 0 at, draw a little arrow, and this will be our answer, because they're already in order. I had to rewrite all these because they weren't in order, but. So now let's think about how that helps me graph this. I start at 0, and I'm going to rotate around to pi 6. Well, at pi 6, my radius has to be back here at 0. So as I rotate around, it's got to go like that. Then my next 0 is at pi halves. And I have a point out here at 2 pi thirds. That means I'd have to start at pi halves and come out like that. Then I'm going to 5 pi 6. So it would come in like so. And then 7 pi 6. So I can't go out any farther than that. Can't go out any farther than 3 pi halves. Can't go out any farther than 11 pi 6. So something like that, but a whole lot better. So does this have symmetry if it was drawn better? Yeah, what kind of symmetry? It has polar axis symmetry and pole symmetry, right? Doesn't it have polar axis symmetry? Yes, and it has pole symmetry. Does it have pole symmetry? Can I rotate it 180 degrees? No. If I rotate it 180 degrees, it's not going to look the same. I only have polar axis symmetry here. Okay? Does that make sense to you? But you will get to where you can look at these and you know it's going to be a rose with however many petals. So once you can get one of the petals, then you'll know where the other ones are. Plus, if you can get this part of the graph drawn, then you should be able to reflect it and get the other part of the graph drawn. That sort of thing. We're not there yet, but we'll get there. Okay? Any questions at all? All right, I'm going to get you started on the last one, just because it starts a little bit different, and then I'm going to have you work through it. So we're going to start with our maximum R values. This is 2 pi, so that means that the cosine of 2 theta is less than or equal to 1, greater than or equal to negative 1. So I say if cosine of 2 theta equals negative 1, then the absolute value of r equals, well, this is r squared. So to get r, I'm going to take the square root of both sides, right? So it's the absolute value of the square root of 36 times a negative 1. Okay, well, what's the square root of 36 times a negative 1? It's an imaginary number, and we're only concerned with the real numbers right here, so technically this doesn't give us anything. This is the empty set. Empty set looks like a 0 with a line through it. So we don't get any answers out of that. You will get answers out of the other one, though. It's not another empty set. So go ahead and finish this part up. Once you get this, start like attempting to graph it, right? Get your zeros, attempt to graph it. I'll give you some time to get that done. Get your zeros too. Go ahead and get the zeros and get it graphed. Okay, make sure you attempt the graph too. I'll talk you through the graph here in just a minute. All right, are we ready to talk about the graph? We know we have our radius at 0, pi, 2 pi. We got a 0 somewhere, right? So if we start here, our first 0 is at pi fourths, so this has got to come out something like that. And then we have another one at 3 pi fourths right here. So this is going to have to come out something like this. This is actually more like balloony looking than the other one was, but oh, okay, I can't do it from the side. Hang on. Oh, that still not good, but good enough for now. And they're not pointy; they're curvy. And when you tend to do it in sections, it's like, oh, that's really bad, like really, really bad. Let me back up some. See if I can do it better. I have to stand in front of it to make it look decent. Okay, that's still not great because it's puffier than that, but it's good enough for the talking purposes. What kind of symmetry does this have? Polar axis symmetry, right? Does it have pole symmetry? Does it have pi halves symmetry? It has all of them, right? So here's why this is important. When you actually start applying these graphs in calculus, and you have to find the area inside of here, then if you can just find the area of this little piece, then you can do what with it? Multiply it by 4, right? Or when you're trying to graph it, you can get that, and if you know what it's supposed to look like, you can reflect it, and you don't have to go and calculate all that stuff. Okay, does that make sense? So there's reasons that all that stuff is going to be important for us. Any questions at all? All right, look at the assignment real quick. It has 2 sides. One of the sides you're going to ignore. Ignore the side with no graphs, because the questions aren't exactly the same. They're kind of the same, but not all of them. So just ignore the side that doesn't have graphs on it. You can use it to work on whatever. The side that does have the graphs on it, I did not take off the 0 to 2 pi halves thing in each question. You can really just ignore that. That's what we're doing anyway. It just isn't written that way, and it might be confusing to you. So I took it off when I didn't have the graphs. Then when I went to put the graphs on there, it's not as easy as smacking a graph on the paper. You would think it is, but it's not. So you can just kind of ignore it. You don't have to scratch it out or anything. It's not wrong. It's just that is what we did, right? Our thetas were between 0 and 2 pi in the end. So, right? You only have 3 of them to do. Attempt the graphs. Just do what you think kind of makes sense, and you might surprise yourself, okay? We good? All righty. Get to work.